Modern artificial intelligence moves at a speed that can feel overwhelming. A user types a prompt, and a system instantly generates code, art, or analysis. To an outside observer, the sheer velocity of the output makes the process look like magic. This complexity usually triggers two specific reactions. We either adopt a pretense of understanding to protect our ego, or we develop a deep fear of being replaced by a black box we can no longer control. In reality, a mystery is rarely magic. It is simply a system that we have not yet deconstructed into its original parts. To strip away the fear of AI, we have to look past technical jargon. We can set aside terms like neural networks for a moment and return to the ground floor, our own ability to observe and ask questions. Intelligence begins with a person noticing a pattern. We see repetition, we identify structure, and we find relationships within the noise. This innate human curiosity is the actual starting point for every machine learning system ever built. The first step in building a machine that thinks is translation. We take qualitative experiences, like a person's preferences, behaviors, or words, and convert them into measurable numbers. These new numbers act as spatial coordinates. By assigning values to different traits, we can place every piece of data as a specific point within a vast mathematical space. This spatial arrangement reveals the core logic of prediction. Distance represents similarity. When points lock into a cluster, the real-world concepts they represent are nearly identical. Programming languages like Python navigate these spaces, building logical pathways between clusters to organize these mathematical relationships at scale. Mathematics provides the structure, and code makes it operational. Together, they allow us to take human logic and apply it to datasets far too large for a single mind to process. When we remove the layers of abstraction, artificial intelligence reveals itself as a sequence of structured mathematics. It operates within a continuous, repetitive loop. This pipeline illustrates the system's four-step architecture: input, a mathematical transformation, a decision, and improvement. The system learns by measuring its mistakes. It calculates the error from the correct answer and feeds it back into the loop to adjust its internal mathematical weights. This loop creates a highly efficient pattern recognizer, but it also creates a system that is entirely meaning blind. A model can identify the exact pixel values that constitute a cat and classify the animal with perfect accuracy. However, it possesses no concept of what a living creature is. It has never felt the texture of fur or understood the purpose of a pet. The machine can optimize a target with absolute precision, yet it remains unaware of the real-world value or the human consequences of the goal it is chasing. As we reach the top of the intelligence ladder, we have to ask a final question. If a machine can independently learn and correct its own errors, can it eventually acquire wisdom? In the living world, intelligence is tied to feedback that actually matters. We feel pain when we fail, we suffer fatigue from effort, and we live with the physical weight of our choices. However, a machine lacks this embodiment. It processes data without ever feeling the force of its own impacts. Because AI is blind to unwritten human history, emotional context, and social dignity, it cannot carry moral accountability. It can follow a rule, but it cannot understand the sanctity of the person affected by that rule. This creates a hard boundary for automation. At the last mile, the point where a decision actually touches human lives, health, or freedom, human review is the only mechanism that can provide genuine oversight. Rather than competing with machines on the basis of raw calculation, our focus should shift toward cultivating the judgment that systems cannot borrow. Artificial intelligence may calculate the fastest path forward, but only human wisdom can take responsibility for the destination.